Hello! This video is going to look at the different aspects of a polynomial function. So we can see here it says a polynomial function is a function of the form f of x is equal to a sub n x to the nth power plus a sub n minus 1 x to the n minus 1 plus da da da. That means there can be a lot more in between here. A sub 1 x plus a sub 0. Now that could be really intimidating, but it's not as bad as it really looks. Our requirement is that a sub n cannot be equal to 0. A sub n right here, that's the coefficient. And we just can't have that coefficient being equal to 0, because if the coefficient's equal to 0, then that x term isn't going to exist there. And n is going to be your first term. We need to have it so that all the exponents are whole numbers. And we've gone through that whole presentation about the difference between whole numbers and natural numbers and integers. So we know what a whole number is. And the coefficients, those coefficients, they have to be real numbers. Okay, when we look at the different aspects of the polynomial equation, we have the leading coefficient. So we know what a coefficient is, it's the multiplier. The leading means it's going to be the first. So the leading coefficient is the coefficient with the term that has the highest exponent. The leading coefficient is going to be the coefficient that goes with the term that has the highest exponent. So if our equation is going to be in standard form, which is our last one down here, it means it's going to be the first coefficient with the first term, assuming it's in standard form. The constant term is the term with no variable. So for example, let's say we have 4x squared plus 2x minus 5. Your minus 5 is going to be the constant term because that's the term without the variable. So that's your a sub 0. Next in the polynomial equation, you have the degree. The degree is the highest exponent. So if you look along all of the terms in your equation, you're going to look for the one that has the x with the highest exponent. Whichever term has the highest exponent, that's the degree. And remember, the leading coefficient is the coefficient with that highest exponent, which is the degree. So the leading coefficient goes with the degree. Now all of this becomes easier if your equation is in standard form. Standard form is when the terms are written in descending order. We know descending order means that we're going from the highest exponent to the lowest exponent. So standard form, highest exponent to lowest exponent, equation written in descending order. When your equation is in standard form, it makes the leading coefficient the first coefficient and the degree the first term. All right, so when we have our equation and we have identified the degree, if my degree, my highest exponent, is 0, then we have a constant. If the highest degree or the highest exponent is going to be 1, that means that we have a linear equation. That's what Algebra 1 was focused on. If we have a second degree polynomial, then we have a quadratic. That's what we have spent the majority of the semester learning about and solving are those quadratic equations. If it's a third degree polynomial, then it's going to be a cubic. If it's a fourth degree polynomial, then it's going to be a quartic. And then it keeps on going on. There's many names as we get larger. Those are just the ones that we generally focus on. Okay, so a reminder what we wanted about before, what a polynomial function is. We want to determine if what I gave you is a polynomial function or not. If it is, then we're going to write it in standard form. We're going to state its degree, the type, and the leading coefficient. So as I'm looking through, remember we've got to consider, we want to make sure that all of the exponents are whole numbers and that all the coefficients are real numbers. Those are the things that we need to look at. So I look, here's my exponent of 2, here's my exponent of x. So this is going to be a no because you have an exponent of x. Which is not a whole number. All right, moving on to number 2. We check our exponents. We have exponents 4, 5, and this would be, it's not written there and we would never write this, but that means that this would be 0. Again, we never write it because anything to the 0 power is going to be equal to 1. So it passes the exponents test. Then we look at the coefficients. That is a real number. Remember, everything's a real number unless it's imaginary, which means we can't have negatives underneath that square root. All of my coefficients are real numbers, so this is going to be a yes. If I write it in standard form, we need that highest exponent first, which is that middle term, the x to the 5th power. So we have the square root of x to the 5th, and then negative 0.08 x to the 4th minus 12. The next thing we want is its degree. The degree is the highest exponent, so in this case, 5. And then I'm going to go to leading coefficient next. LC leading coefficient. And remember, the leading coefficient is going to be the coefficient that goes along with that first term. So that's going to be the square root of 2. Because the degree is 5, this was not on your list, but it's going to be quintic. All right, our last one, j of x is equal to x squared plus 7x to the negative 1st minus 6x cubed plus 2. So the first thing we check is, are those exponents whole numbers? Yes, no. Remember, whole numbers are not integer. The negative 1 is an integer. We want it to be greater than 1. So we have no, because the exponent of a negative 1 is not a whole number. Okay, and that is it for today.